Hello everyone, welcome to this session. We are going to start today linear equation system and we'll try to understand how to solve the all types of linear algebraic system of equations. But before we start, let me just confirm one thing that Sujata Bhamre ma'am might have taught you the definition of rank and how to find out the rank for any given matrix A of order m cross n. If this part is clear to you, then we can proceed to solve the system of linear algebraic equations because the rank is crucial to understand the solution of the system of linear algebraic equations. Right? Okay. Now let me elaborate first of all what this system of linear equations means. Actually, it is a collection of one or more linear means each of the variable is having degree 1 and no two variables are in product. So one or more linear equations involving the same set of variables. For example, here you can look into, we are having three equations in three variables. Many of the times when we are having number of equations is equal to number of variables, such systems are called as the square systems. Else we may have m equations in terms of n variables. So we are having here three equations in terms of three variables x, y, z. So such a system can be converted in terms of matrix notation, and further we can find out the rank, and with the help of rank we can solve this system as well. Before we proceed to the matrix notation, let us understand the independent and dependent variables. It's really important to understand this. Suppose we are having m equations in n number of variables, then few things we can acknowledge clearly. If m is equal to n, then all n variables are dependent. If m is less than n, then n minus m variables are independent, means they can take any value, and m variables are dependent variables. Now let us try to understand this particular aspect through one example. Now see this example number 1. I'm having equation x plus y is equal to 2. That means this is the single equation. So I'll write down here one equation in two variables. Right? So what is the value of m here? It's 1. And what is the value of n here? It's 2. Right? So out of this two, x and y, one variable I can assume as, say, t, a parameter. Right? And if y is equal to t, then x I can write down as 2 minus t. So my solution appears like x is equal to 2 minus t and y is equal to t, where this parameter, I'm sorry, where this parameter seems to be the free parameter. It can take any value. So number of equations and number of variables are important over here. Let us take one more example. X plus y is equal to 2 and x minus y is equal to 0. Now we are having two equations in two variables. Now both of the variables are dependent because number of equations and number of variables are similar. And in this case, we can find out values of x and y by solving both of the equations or all equations simultaneously. Alright, and solving it simultaneously for this system, we are going to get x is equal to 1, y is equal to 1. Hence, both variables are dependent variables. Now let us understand the general form of system of linear algebraic equations. Again, as I discussed earlier, we are going to consider m linear equations and n unknowns, that means variables. Earlier, we have used this term variables, so we can continue with that. So, first equation is a11 x1 plus a12 x2 plus a13x3 plus and so on, a1 and xn is equal to b1. So that's your first equation. Then a21x1 plus a22x2 plus a23x3 plus and so on, a2 and xn is equal to b2. So that's your second equation. And so on. We can continue likewise, and the last equation we are going to consider as am1x1 plus am2x2 plus am3x3 and so on, amn xn is equal to b1. So that's your mth equation, right? Now, what are these notations? We'll try to understand, or symbols. x1, x2, x3 and so on, xn. These are the unknowns or variables. Then a11, a12 and so on, amn. These are your coefficients of all variables into that system, right? And lastly, b1, b2, b3 and so on, bm. These are your constant terms. So if we understand the set of understood the set of equations properly, now let us try to abbreviate it. Now how to abbreviate this system of equations, let us try to understand. So here I have, this is the system of equations in terms of matrix in this way. So all coefficients we have collected over here in this matrix, and this is called as the coefficient matrix. Generally, this coefficient matrix we are going to denote with the help of A. Then this is matrix of unknowns. Matrix of unknowns or variables. Correct? And this is the RHS matrix. So generally this is termed as B. Matrix of unknowns, it is generally termed as capital X. So using this particular notation, our entire system is now can be written in terms of Ax is equal to B. Correct? So you can observe over here, this particular product is feasible as this coefficient matrix is having order m cross n. Matrix of unknowns, this is having rank n cross 1, and hence the product, as your number of columns is equal to number of rows, product is feasible and the resultant matrix will have its order m cross 1. So compatibility of this matrix multiplication is possible over here, and hence the entire system can be converted in this way. So here onwards your notation must be this one to denote system of linear algebraic equations. Obviously, the entire things are depending on how this system of equations we are representing, what is the order of this system of equations, how many variables, and based on that the further things can be proceeded. Now once we define the system of linear algebraic equation, which is Ax is equal to B, these two matrices on either of the sides we can join, and these joint matrices are called as the augmented matrix. So the notation can be this one, or some reference books can have the notation in this way as well. A dotted line, this is B, and so on. So what we are doing, we are just joining the coefficient matrix with a vertical line, this right hand side matrix, capital B, right? And this is called as an augmented matrix. The literal meaning of augmented is joined. Now, before we proceed, we need to understand the geometrical interpretation of the system of linear algebraic equation. As it is very feasible for us to look down into system of equations which can easily observable, like 2 cross 2 system of equations we can consider, as we know that 2 cross 2 system of equations can be considered in two-dimensional plane, right? And the second thing which can easily observe is the system of equations which are in three-dimensional space, means three equations in terms of three variables. So considering that particular part, geometrical interpretation we can imagine through certain figures, and these figures I'm going to explain you over here. Now system of equations may have different types of solutions. Maybe all of these systems are solvable, may not be solvable, or sometimes they may have more than one solution as well. So in what cases they are having more than one solution, that we will try to understand properly. Give me a minute just to connect my PC. Yeah. Yes. Now, let us understand these geometric interpretations step by step. A linear system in three variables determines a collection of planes, the intersection of point in the solution. The linear system may have three types of solution as I discussed: infinitely many solutions, unique solution, and no solution. Now let us try to understand what the unique solution means. Suppose we are having three planes. Let me just point it out. This is your plane A, this is your plane B, and this dark blue shade is your plane C. So these planes are intersecting with each other at a single point, which is this one. And hence, we are treating this as the unique solution for all of these three equations in terms of three variables, which are nothing but the actually equations of the plane. Infinite solution. Three different planes intersect in a line like this, figure A. Two planes are same and the third plane intersect them in a line like this, figure B. We are having this line as the solution. Let me take another color. This line as the solution, and when it comes to line, we are having infinitely points on that particular line, and hence the system is having infinitely many solutions. It may happen that all these three planes are same. So like this figure C, we are having infinitely many solutions over here. And no solution, we are having these many options for no solution. The planes are different but all are parallel like this figure A. So we don't have any solution to this. Two planes are parallel and third is crossing them. So this can be the pattern. So no solution to the system together, we can say. The planes are different, none are the parallel, but the lines of intersection of each pair are parallel. So यहाँ पर हम parallel line को बोल सकते हैं, and here is the situation where no solution, common solution is there for all three equations together. Two planes are same and parallel to third. I'm sorry. This is the case D, which is this last one. And this case, the two planes are different, but none are parallel. But the lines of intersection of the each pair is parallel. So here you can look at ये दो plane intersect कर रहे. This is the line of intersection. This is line of intersection, and here, which is visible and at the back side, this is also line of intersection of these two planes. Okay. So this is your C case. So in all four cases, we are having no solution to the system. So this is the geometrical interpretation of system of linear algebraic equations. And now let us focus on how we should proceed further to solve the system of linear algebraic equations manually. So consider a non-homogeneous system of equations. Ax is equal to b with m equations and n variables, and with matrix B, which is a non-zero matrix. Now here we are having one more different word associated with this linear system called as a non-homogeneous system. Now when it comes to the representation, Ax is equal to b, this is our system of linear algebraic equations. Now it is said to be, number one, non-homogeneous if capital B is not equal to 0, and second, it is said to be homogeneous if B is equal to 0. So for both of the cases, if it is non-homogeneous, if it is homogeneous, how to find out the solution, that we are going to track out. So that will be the entire discussion for this particular session. Now, what we are going to focus on, the consistency of the system or inconsistency of the system. So system is said to be consistent, means having solution. Having solution if rank of A is equal to rank of your augmented matrix and it is equal to R. So when we are saying that Ax is equal to B is our system, what we are further forming from this? Your augmented matrix. Now, once you are having augmented matrix, so this is your coefficient matrix, vertical line, and this is your right hand side matrix. So this matrix gives you rank of A, and the entire matrix gives you rank of AB. So what we are trying to focus, both of the ranks, if it is if equal and equal to say certain R, then this entire system is said to be consistent. And if the ranks are not equal, then system is said to be inconsistent, means has no solution. Okay, okay. Let us proceed further. Type of solutions: unique solution, infinitely many solutions, and no solution. Now, instead of explaining the type of solution point wise or step wise, let me just explain this in terms of chart. Give me a minute. I'll take one more additional page here to explain you this particular fact. Hmm. Okay. So let me explain you in terms of flowchart so that you can remember it very well. So again, I'm going to consider over here a system of equation X is equal to B. So I will abbreviate this as system of linear algebraic equations, right? And now I'm composing here certain conditions. What type of conditions? So B is not equal to 0. I'm going to consider this as case A, comma. M are your equations and N is equal to your variables. Got it? So once you have this particular system which is a non-homogeneous, B is not equal to 0 means non-homogeneous system of linear algebraic equations. Okay? Now next is we are going to form augmented matrix in this way. Correct? Next to that, we are going to find out the ranks over here. Right? Find rank using echelon form. Now, when we are finding out the rank using echelon form, this is nothing but our Gauss elimination method to solve the system of linear algebraic equation. Now, in your syllabus, it is simply given as the solution of linear system. So that involve lot of methods: Gauss elimination method, Gauss-Jordan method, then sometimes power method as well, and further this matrix method. So we are focusing on the matrix method, which is very similar to the Gauss elimination method, and with echelon form we are applying that particular format in a little different way. So finding out the rank by using echelon form gives us further this particular prediction or insights about our system. So what you are finding out here, it's rank of A, right, and rank of AB. So once you have it, you are having two different options from here. Number one, rank of A, that is coefficient matrix, is equal to rank of augmented matrix, and it is equal to say R. Means both of ranks are equal and equal to R. And second case is rank of A is not equal to rank of AB. So that two possibilities are there. So first of all, we'll see this possibility here. Let me get the color change once again. So here the conclusion we can do that system of linear algebraic equations are inconsistent. Means has no solution. So that's our conclusion. But if both ranks are equal, again here we are having two options. Number one, this rank which is we are saying as R, it's equal to n. What is n? Number of variables. अगर rank equal है and equal to number of variables है, in that case we are having unique solution. It's consistent and has unique solution. And when this R is less than n number of variables once again, correct? Then in this case, system of linear algebraic equation is consistent and has infinite solution. Correct? Now another aspect is that अगर यूनिक सॉल्यूशन है तो हमें यहां पर सॉल्यूशन फाइंड आउट करना पड़ेगा. करेक्ट? एंड अगर इनफाइनाइट सॉल्यूशन है तो यहां पर भी आपको सॉल्यूशन फाइंड आउट करना पड़ेगा. I repeat once again, agar both of the ranks are equal, you are having your system of equations as consistent one, having solution, either unique or infinite. And if ranks are not equal, then system of linear algebraic equations are inconsistent, having no solution at all. So this chart we discussed for what type? Non-homogeneous type, correct? And now for each of this case, one problem we can solve. Now before we go for the problem solution, let us try to understand a similar tree chart for our second type. What is that second type? I'll just write down that once again. This is type B, which is homogeneous system of linear algebraic equations. Right? Now once again in similar fashion, let us consider Ax is equal to B as your system, right? Where B is completely equal to 0, M is equal to your equations and N is equal to your variables, number of variables. Alright. So if this thing we are having, then what further we have to understand? A and B ka association joining, which are we call as the joined matrix or augmented matrix. But I will make your star and all of you can answer after discussion of this particular point whether the augmented matrix is needed for homogeneous system of linear algebraic equations or not. Okay, why I'm asking? So let me elaborate here. Suppose you are having this Ax is equal to B as the system and I'm checking here my augmented matrix. Okay, now that augmented matrix, coefficient matrix can be in this way: A11, A12, and so on, A1n, right? Then A21, A22, and so on, A2n, and so on, AM1, AM2, and so on, AMN. So that's your coefficient matrix. Now vertical line I will put up as B is the completely zero matrix, 0, 0, and so on 0. So this is your augmented matrix for the homogeneous system of linear algebraic equations. Am I right? Now focus on the ranks which we can receive here. Now this gives you rank of A, correct? And this entire matrix will give you rank of AB. Now tell me that whether that last column, which is this one, is contributing into the rank? No, right? So whatever rank this coefficient matrix is having, same will be the rank of that augmented matrix, right? Means for homogeneous system of linear algebraic equations, rank of A is always equal to rank of AB. correct? And that's why if you are going to consider an augmented matrix that may not be needed over here, I can simply find out here rank of A. So I'll write down in this flow chart get rank of A, which is equal to rank of AB. So this is the crucial step and that's why this star I mentioned over here. So अगर आपके rank of A and rank of AB दोनों भी equal ही होती है homogeneous system of equations के लिए, तो हमारे पास एक important conclusion क्या आ जाता है? Homogeneous system of linear algebraic equations are always consistent. क्योंकि रैंक्स अनइक्वल होने की यहाँ पर कोई पॉसिबिलिटी नहीं है. So homogeneous system of linear algebraic equations are always consistent. Got it? Yes. Now if this fact we are knowing, two possibilities here we may have. Ranks are equal, correct, and is equal to R but is equal to N, correct. Then in this case, system of linear algebraic equations have, sorry, I'm saying a system of linear algebraic equation has unique solution. And that unique solution can be directly treated as x1 is equal to x2 is equal to x3 is equal to and so on xn is equal to 0. And as this is a trivial solution, by default solution, unique solution can also be named as trivial solution. And second possibility under this is if rank of A is equal to R but it is less than N. What is N? Number of variables. In that case, your system of linear algebraic equation has infinite solution. And we need to find this solution. In case of unique solution or trivial solution you can write down directly. But in case of infinite solution, you need to find out the solution. Now, as we have given trivial word in for the unique solution of a homogeneous system of linear algebraic equation, we are also having a similar type of word for infinite solution. The infinite solution can also be called in this case as non-trivial solutions. So these are the two types of linear algebraic systems, and this is the flowchart that represents the variety of type of solution a given system is having. That's it for this particular system and discussion. Solution of each type of the system of linear algebraic equations we will discuss in subsequent lecture. Thank you everyone.